Hello everyone. I am Dr. Shannon Pal from IM Newtown UM Kolkata, and today we'll be learning about understanding color coded resistors. It is one of the basic things that we must learn for our electrical and electronics laboratory, and we will be learning basics about the resistors. As we all know that resistors has a symbol like this, whereas small resistors used in electrical as well as electronic circuits looks like this with different color codes in it. These color codes or these colors come in different combinations. There are different kinds of colors with different combinations signifying different values for each resistors. Today we are going to learn about the colors, what each color signifies, what their combination makes, and what becomes the value of the resistors which we are going to use in our circuits. For example, the colors which are assigned in our resistors are 12 in number. They are as black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, and silver. Out of these 12 colors in this particular sequence, they are assigned a certain digit. For example, black is assigned a digit 0, brown is assigned a digit 1, red as 2, orange as 3, yellow as 4, green as 5, blue as 6, violet 7, gray 8, and white 9. The other two colors, that is gold and silver, are not assigned any particular significant digit. Next comes multiplier. Multiplier is a number which is used for multiplying. When we will learn the color coded resistors, actually we will find it out. But this multiplier comes in lieu with this digit. For example, if a digit for black is 0, then the multiplier value is 10 to the power 0, that is 1. For brown, since the color brown has a digit or significant digit as 1, then the multiplier is 10 to the power 1, signifying the multiplier value as 10. Red being 2, the multiplier value is 10 to the power 2 or 100. Orange being 3, the multiplier value is 10 to the power 3 or 1000. Yellow being 4, the multiplier value is 10 to the power 4. Green 10 to the power 5. Blue is 10 to the power 6, that is 1 million. Violet being assigned 7 is having 10 million as the multiplier value. Gray 8 is having 100 million as the multiplier value. White as 9 is having a multiplier value of 10 to the power 9, that is 1 giga. Gold and silver also has a multiplier value which is 0.1, that is 10 to the power minus 1, and silver having 0.01, that is 10 to the power minus 2 as multiplier values. Also, there are some tolerance values which are assigned to each color. For example, brown has a tolerance value of plus or minus 1. Red has a tolerance value of plus or minus 2. Whereas green, blue, violet, gray are also assigned some tolerance values. The most significant tolerance values are gold, that is plus or minus 5, silver, that is plus or minus 10. And if there is no color in the tolerance band, we consider it as plus or minus 20%. Now this color coded resistors which we have seen has certain digit, certain multiplier, and also certain tolerance. Tolerance is because that resistance actually changes with temperature, with different physical conditions. So and also due to some manufacturing there can be some error. So tolerance is given due to all these factors. One of the easiest way to remember this color in this particular sequence is B.B. Roy, Great Britain, very good wife. B.B. Roy, that is black, brown, red, orange, yellow. Great signifying green, Britain signifying blue, very signifying violet, good, gray, wife, white. This is the easiest way, or this is the easy sequel given to understand or remember the sequence of colors. Now we will see that how a 4-band resistor and a 5-band resistor comes into picture. For a 4-band resistor, there are 4 particular bands. The band which is having the distance, a greater distance between the two bands, the last band which is having a greater distance is actually considered as a tolerance band. It is kept on the right hand side and the digit counting starts from the left hand side. For a 4-band resistor, the leftmost band is actually the first significant digit. The second band is the second significant digit. The third band shows the multiplier and the fourth band is the tolerance. Similarly, for a 5-band resistor, the first band is the significant digit, the second and third band also are the significant digits. The fifth band is the multiplier and the fourth band is the multiplier and the fifth band is the tolerance value. Now let us take some example of 4-band resistors. Let the first one be having bands like yellow, violet, brown and gold. Now for yellow, violet, we will be assigning some significant digits. For brown being the third band, it is the multiplier band, and gold being the last or tolerance band will give some tolerance value. As we know, the assigned value for yellow is 4. For violet, the significant digit is 7. For brown, the multiplier value is 10 to the power 1, that is 10. And for gold, the tolerance value is plus or minus 5. So the value comes down to 470 ohms with a plus or minus 5% value change. That is, the value ranges from 446.5 ohms to 493.5 ohms. This is how a real 470 ohm resistor looks like. Let us take another example with red, red, orange and gold as the combination. The first two bands being red and red will have significant digits as 2 and 2. Orange has a multiplier value of 10 to the power 3, that is 1000, and gold is again having a tolerance value of plus or minus 5%. So the value comes down to 22 kilo ohms or 22000 ohms with a plus or minus 5% change. That is 20.9 kilo ohm to 23.1 kilo ohm is the range of this resistor. This is how it looks like. An example of 5-band resistor. We have taken an example with red, red, black, brown, brown. The last brown being the tolerance band because it is having the maximum distance between the two bands. Now for red and black, the significant digits are 2, 2 and 0 respectively. The fourth band being the multiplier band, that is brown, 10 to the power 1 or 10. And the last brown signifies a tolerance value of plus or minus 1%. So the value comes down to 2200 ohms with a plus or minus 1% change. That is, it ranges between the value of this resistance ranges between 2178 ohm to 2222 ohms or 2.178 kilo ohm to 2.222 kilo ohms. This is how it looks like. Now the significance of studying this color-coded resistors in circuit design mainly. The understanding of this color-coded resistors helps us or gives us idea of the value of the resistors in complex and compact electronic circuits. It also helps us in troubleshooting. Knowledge of color code aids us to effectively troubleshoot the different electronic components. We will definitely see application of these resistors in different circuits in the later videos. Thank you for now.